Okay, so here we are. We're going to be working with ionic bond diagrams. And remember, ionic bonds are formed when a metal transfers its electron to a nonmetal. Ionic bond diagrams are trying to represent this type of exchange in sort of a visual format. So I'm going to start with an example and show you what we're going to do. You'll notice I have potassium, which is a metal, and iodine, which is a nonmetal. Remember, I know that because anything, if you find that step line, metals are always to the left of the step line and nonmetals are always to the right of the step line on the periodic table. So make sure you're paying attention to that. It won't matter so much today because we're just doing ionic, but when you get to the mixed ones tomorrow with the covalent and ionic, you have to be able to identify what's what. So we have our metal, which is potassium, and our nonmetal, which is iodine. We're going to start this process by drawing electron dot diagrams for both of them. So potassium has one valence electron, so I'm going to put my K with one dot next to it. And my iodine, when I look at that, it's in group 17, so I know it has 7 valence electrons. And so I'm going to have 2 on each side, except for the last side, I'm going to have just 1. So in terms of what's happening for an electron structure and when an electron or an ionic bond forms, we're going to take this potassium ion and we're going to transfer it over here to the iodide ion. And so we're going to actually have that that electron leave the potassium and go to the iodine. And when it does, what we're going to end up with is a potassium ion that has a +1 charge. And what this is representing, what I've just drawn there, is my potassium ion. Notice I'm not putting any dots around it because it's already lost its valence electron. And then I'm also going to have my iodide ion over here. And I'm going to put my dots all around my iodide ion, and I'm going to put it in a bracket to show that this is all together. Now notice this very last one, I'm just going to do it in red here so that you can sort of keep track of which ones came from the potassium and which ones come from, whoops, sorry, let me get rid of that. Which ones come from the potassium and which ones come from the iodine. And so I have my I, and of course if it's gained an electron, it's going to have a -1 charge. Now in this case, potassium forms a +1, iodide forms a -1 because, excuse me, potassium has 1 ion to lose and iodine needs to gain 1 ion to get its valence electrons. So because it works out so nicely, we don't need to worry about having multiples of each of these. Now, what this eventually tells me is the ratio of potassium to iodine in a formula. And so the final formula is just going to be Ki. I have 1 potassium and 1 iodide. And then we're done. Pretty straightforward. Now, let's take a look at another. This example is strontium and tellurium. So we're going to start in the same place. I'm going to start by writing my strontium and doing my dot diagram. I have 1 dot, 2 dots, because I know strontium is in group 2, so it has 2 valence electrons. Tellurium, Te, is in group 16, so it has 6 valence electrons. So 1, 2, 3, 4, 5, 6. And so what's going to happen here when I do my transfer of electrons, one of these is going to go over here, So there we go. So I've got my 2 from the calcium, and my chlorine has 7, which means calcium wants to give up 2, but chlorine only wants to gain 1. And so what's going to happen here, this 1 will go over here to the chlorine, and the chlorine is good to go at this point, except I still have 1 more valence electron that I've got to get rid of. This calcium electron here has to go somewhere. And so what's going to happen is we're going to include another chlorine, because another chlorine can now pick up, if it has its 7 valence electrons, can now pick up 1 more of calcium's electrons. And so when I go to write this out nice and neatly, my calcium, of course, is going to end up with a +2 charge. I need to switch pages. With a +2 charge, and I need 2 chlorines, each of which is going to look like this. It's going to have a full valence shell, and it's going to be a -1 charge. And so when we go to write the formula for this, I'm going to write a formula. I need 1 calcium and I need 2 chlorines, so I can put a subscript of 2 after the Cl. And so what we end up with is CaCl2. The last, is a really complicated one because what we're going to have here is aluminum, which if you remember, and I draw my Lewis structure, Al has 3 valence electrons, so there's 1, 2, 3, and oxygen has 6 valence electrons. 1, 2, 3, 4, 5, 6 is what this one looks like. So aluminum needs to get rid of 3, and oxygen needs to gain 2. So if my first one, my first aluminum, I lose this one over here, I lose this one, and this oxygen picks it up. But now I still have this one over here that has to go somewhere. So I'm going to add another oxygen to the mix with its 6 valence electrons, and it's going to pick up this electron over here. But unfortunately, the oxygen still needs 1 more electron. And so it's going to take another aluminum with its 3 valence electrons, and this here aluminum is going to pick up and put in that last one, but now my aluminum still has 2. And so I'm going to get 1 more oxygen that needs these last 2 electrons. And so my aluminum 1 will go here, this one will go here, and then finally I'm going to be able to write my structure, 2 aluminums that are going to end up with a +3 charge because they've lost 3 electrons, and 3 oxygens that are going to end up with all of the electrons. So I'm going to draw my Lewis structure with the 8 dots, and I'm going to give it a -2 charge because each one had to gain 2 electrons. And when I write the formula for that, I'm going to get Al2O3. Another way of looking at this that kind of makes it sort of a little bit easier, and you can do this as a shortcut if this makes sense to you. Hang on just 1 second here. Come on. Okay. If this makes sense here, what you can do actually is, I'm just going to move this up here just a little bit so I have a little bit more room to write. I can look at this as my aluminum is going to lose 3 electrons. My oxygen, right, because it's got 3 valence electrons on it, my oxygen has 6 valence electrons, and so it's going to gain 2 electrons. And the multiple between the 3 electrons lost and the 2 electrons gained, the multiple is 6. And so what it's going to do, it's going to take 2 of the aluminums and 3 of the oxygens to transfer that total of 6 electrons. Each aluminum loses 3, so I need 2 of them. Each oxygen gains 2, so I need 3 of them, and I've transferred a total of 6 electrons. And so rather than drawing out this whole big picture kind of thing here, you can kind of look at it just like this down here as far as the gain and lost. So what I want you to do is go on to the practice sheet in your packet and work on that one. The key is on Schoology on that page, so click on the next page, take a look, click on the key at the bottom. You can follow along as you go. If you've got questions, don't forget that the discussion board is there, and I will check it as much as I can.